Hello friends. So here we are going to start our first subject, which is optical instrumentation. So as far as optical instrumentation is concerned, we have uh, 7 topics in general from the optical instrumentation. In case of gate and PSUs, so the first topic is basic optics. In this topic, we are going to deal with the very basic level of optical instrumentation, like our reflection, refraction, total internal reflection, all those phenomena. The next part is the fiber optics, where we are going to deal with the optical fiber, like step index, gradient index, fiber. All these things we are going to cover in the fiber optics. The third topic will be laser, fourth will be LED, fifth will be photodiode, and sixth will be photoresistor, and the last is interference. Like these three topics are very basic topics till the lasers, and these three topics, LED, photodiode, and photoresistor, are very small topics. And this interference, we are going to see Michelson interferometer and Young's double slit experiment. These two at the last we are going to see in the interference. So this is very small syllabus for the optical instrumentation as far as the gate instrumentation is concerned. And there is another topic which are basically from the analytical instrumentation. So I will be providing a separate series that will be very short series for sure. And yeah, that I'll provide once I complete the optical instrumentation. Nearly in 2 to 3 days I complete the entire optical instrumentation, as this syllabus is very small. Yeah, so let's start with our first topic, and I will update you regularly. Like in upcoming days, we are going to cover various subjects like transducer and process control, as well as communications, especially as optic instrumentation point of view. So let's move on to the next slide. So basically the theme of this video will be like I will be discussing all the important formulas, concepts related to the each and every topic, and at last I will be giving you a quality questions which are from the topic itself, and which are also part of previous year gate questions. So in that way it will be easy for you to understand the concept and apply it on the questions. And for the answer of the given questions, I will be providing a link for that, or a yeah, link will be better. I will provide a link on which you can see directly the solutions, and those solutions are basically done by me in my own language and method. So yeah, that will be very easy for you to understand. There won't be any printed answers or something. All answers will be verified by me, and they will be very easy to understand. Okay, so yes, let's start with the basic optics, and these are the topics under the basic optics. So first we will be seeing the basics: reflection, refraction, condition of refraction, Brewster law, reflection losses, total internal reflection, and critical angle. These are from the basic. All the topics were asked in previous year gate exam. So let's see from the basic. Okay, so the first point I want to discuss is the as we know, a part of electromagnetic radiation, like EM radiation, there is a part which is under the visible region. So yeah, as far as optical instrumentation is concerned, we are going to deal with the visible domain of the light. So first thing you should remember is the wavelength of the light in the visible region, which is 380 to 780 nanometer. Nearly, you can say it is 400 to 780 or 750 nanometers, like that. Generally, it's easy to remember just because I have written 380 to 780, like the similarity. The next point is the speed of light, which you all know, 3 into 10 to power 8 meter per second. Like you can consider it in the vacuum, or you can generally say it is an air medium. Okay, so next point is the refractive index of a medium. This is very important point. You must remember this point: refractive index of the medium. This is the speed of light in vacuum. Just remember, first you should come as a vacuum on the numerator, and the speed of light in that medium. The easier way to remember is, as we all know, the refractive index of air is 1. So you can say the speed of light is almost similar in the case of vacuum and the medium. And for example, if you say my medium is 1.5 refractive index, so basically we know that more is the refractive index, less is the velocity. So in that way you can inversely relate, like which quantity will come in the numerator or denominator, like that. In that way it will be easy for you to remember, like which velocity is on the top and which velocity is in the denominator. Okay, so in that way you can remember this point, refractive index of a medium. So the next basic point is the ray diagram. Like for example, if you consider this is a surface, or you can say this is air and you consider it as an air, and here you can consider it as a glass. So as the ray which is getting incident on the surface of glass air interface, this is called incident ray. The ray which is reflected back in the same medium is known as reflected ray, and the one which is traveling along the another medium, which is the glass medium, is known as the refracted ray. And this line is also very important. This is the normal line. This line is the normal line. Okay, just for your indication I have showed this is the normal. Okay, and the angle which is subtended with the normal to the incident is known as the incident angle. This is a refracted angle, and this is also a reflection angle which is same as the incident angle. You'll come to know the law of reflection in coming in near future. Yeah. Okay, so the first point is reflection. As we all know, like if there is a mirror and one ray is along the AO line, and it is reflecting along the OB line, such that the angle of reflection, like the angle of incidence, is equals to the angle of reflection. This is the law of reflection. Here one interesting point I want to convey, which is this note point. This is a special case, like if in any competitive exam, if they are asking you like how many number of images will be formed if by means of two mirrors which are kept at an angle. So this is a very efficient way to answer the question is like there is an angle between the two mirrors, so 360 divided by the angle between two mirrors, this is one quantity minus 1 you have to do. These are the number of image formed by this particular setup. So this is one interesting point to note, and you can remember it. Actually, it is very easy to remember also. Okay, so next point we have to think is refraction. As we all know, like in our earlier classes, like class 10th or 12th something, around some 3 to 4 years back, you have studied the phenomena of refraction, and there one law is there which is very famous, Snell's law. Like if you consider two medium, there will be the medium 1 and medium 2. Sorry. Yeah, let's see, there will be two medium, like medium 1 which is having a refractive index of n1, and medium 2 which is having a refractive index of n2. So these 2 points you should keep in mind, like whenever there is a ray which is traveling from rarer medium to denser medium, it always move towards normal. And when there is a when there is a direction of the movement from denser to rarer medium, the light ray bends towards, like bend away from the normal. These 2 points you must remember in mind while uh, uh, understanding the ray diagram of any particular incident ray. Okay, and yeah, one more thing is like this is the condition for the total internal reflection. Like whenever the light is traveling from denser to rarer medium, the total internal reflection is observed. Important points which I want to discuss: the first one is the notation of refractive index. For example, generally we use mu, and if it is written mu 2 1, it means the refractive index of medium 2 with respect to medium 1. In other words, you can say the mu21 is equals to mu2 by mu1, where mu2 is the refractive index of medium 2 with respect to air, and mu1 is the refractive index of medium 1 with respect to air. These are the notation which are very important in case of problem solving, like when you put a lens into the water, what will be the refractive index. Like in those questions, it is very useful. You are going to face such questions in your any workbook or any question bank, so it's fine, you can use this formula over there. The next important formula I want to relate is, as we all know, c equals to nu lambda is a very popular relationship between the velocity, frequency and wavelength. And recently we have studied this formula also, like mu is velocity of light in vacuum divided by velocity of light in medium. Here we know that c is constant, so you can say like refractive index is inversely proportional to the velocity. Like more is the refractive index, less is the velocity of light in that medium. So from here you can just relate this formula, like mu2 by mu1 equals to v2 by v1 equals to lambda 2 by lambda 1, like how the refractive index is related to the wavelength of the light. Like generally they can ask you such questions in case of the relation or a statement type of questions. Okay, so the next topic is the Brewster law. As far as this Brewster law is concerned, very easy questions are there from the Brewster law. So here the first concept is of plane polarized light. What do you mean by the plane polarized light? So if the vibration of lights are confined to one direction only, which is in the plane perpendicular to the direction of propagation of the light, such a light is called the plane polarized light. Okay, so as far as Brewster law is concerned, it is actually a very simple law, mu equal to 10I. Here mu is the refractive index of the medium. So the statement itself is saying like refractive index of a material of a medium equals to the tangent of the angle of the polarization. Here the main crisp is in this diagram. Like here the incident light is unpolarized light, whereas the refracted light and reflected light are making the angle of 90 degree. This angle is known as 90 degree. Here it was observed that this light is a plane polarized light, and reflected light, like the angle between reflected light and the plane polarized light is 90 degree, and the plane polarized light is observed as a reflected light. So in that case the refractive index of this medium is equals to the tangent of the incident angle. So in general this is the Brewster law, uh, how you can relate it. The condition is only that this light observed over here is plane polarized light, and the angle between the refracted light and reflected light is 90 degree. In that case the Brewster law is applicable, and the refractive index of the medium from which it is getting reflected and refracted, that can be related to the mu equals to 10I. Here one interesting question is there, like if you apply angle sum property at the point B, so the as we know that the angle around a single point is all equal to 360 degree. So just add all the angles like I plus 90 degree plus refracted angle plus 90 degree plus this entire angle will be 90 minus I, this angle. So if you solve this equation, you will get the relationship as I plus R equals to 90 degree, which is one important relationship, and you should keep in mind generally to find the refracted angle in case of Brewster law questions. So next topic let's consider is the total internal reflection. As I said, the necessary condition for the total internal reflection is the light ray must travel from denser medium to the rarer medium. This is the compulsory condition to observe the total internal reflection. Okay. Yeah. Let's see, like for example, let's consider the total internal reflection. Here the mu2 is greater than mu1, so the light is traveling from denser medium to the rarer medium, and there is one concept of critical angle, like the minimal angle for the total internal reflection to occur, the angle above which the light will be fully reflected back to the same medium. So this is the minimum angle for the total internal reflection to occur. And yeah, the analysis of critical angle is like in the green color box I have given, like when the light is traveling from denser to rarer medium, and this is the limiting condition of the light ray, like it grazes along the path of the medium interface. So you can apply a Snell's law over the interface, like mu2 sine of theta c equals to mu1, and the refracted angle is 90 degree. So in that case you can consider mu1 sine 90 degree. In that case you can easily find the theta c. Okay, so this is a very simple topic and very easy questions are there. All you need to know is how to apply the Snell's law, and what is the limiting condition for the critical angle, and once we cross the critical angle what gonna happen to our light ray. Yeah, so one more point I want to discuss with you guys. Here the point is the reflection loss. Whenever a light incident on any surface, so it won't get 100% refracted. Some part of the light will get reflected back also. So even in recent years, like around 2002 or 2003, in GATE, one question was asked based on the reflection losses. So here is a simple formula. Uh, for example, mu1 and mu2, light is traveling from mu1 and the surface, the medium which is interfaced is mu2, having the refractive index of mu2. In that case, the formula of reflection loss is equals to mu2 minus mu1 upon mu2 plus mu1 whole square. Don't forget this square. Like generally people commit mistake, like silly mistakes you can say here. So yes, generally the reflection losses are termed in form of percentage losses. So the percentage reflection loss is equals to mu2 minus mu1 upon mu2 plus mu1 whole square into 100%. This formula is important, and one question was asked in GATE 2002 nearly. So this point you should keep in mind. And yeah, in order to reduce the reflection losses, we must incident light normally to the surface. Here is one more point which I want to discuss. Like uh, if you incident the light normally to the surface, there will be less chance of reflection, less chance of reflection losses. So this is also an important point which you should keep in mind during your preparation. Okay. I already discussed total internal reflection, and yeah, let's move to the questions. There are four questions which I have provided: first, second, third, fourth. All are very easy questions, and with the material which I have provided, you can easily solve these questions, and you can understand or you can grasp the concept. And yeah, you can move ahead, and I will be providing you the second part of this video very soon once you uh, understand all these concepts. And yeah, this PDF link is also I am providing in the comment section. I will pin that comment, and you can just use this as your reference, and you can solve those questions, and you can try some other questions as well. And yeah, on the daily basis I will be updating video from today onwards, and very fast I will be covering up all the topics which are basically from the part of core instrumentation. And my preference order is generally in the form of, like, first I will be covering optics, next I will be doing communication. After that I have a mind to go for the transducer, and after that I will be coming to the process control, and later on I'll move to the electricity and magnetism. Like that I will move forward and provide you all the short videos based on my knowledge. Okay friends, thank you very much.